computer or not. So nobody will complete the problems, right? Okay, fine. I won't be solving these problems. So if possible, you itself solve it, and possible you just only. So I cannot do anything. Okay. So we'll be moving on to the next part. So we have covered about linear. Okay. So linear, causal. Okay. Time variance, invariance we have covered. So now we will be dealing with static and dynamic system. Okay. So the third criteria just a minute, I'll be back. Okay. So now we can move to the next system, which is static and dynamic. Okay. So static and dynamic is your third criteria of classification. Okay. So in this, you can say static system as the memoryless system. The other name for static system is memoryless system. So the other name for dynamic system is memory. The system is memory. Okay. So now for consideration, how you can say a system is static or dynamic means in last previous topics and all, how we have seen means we have seen step by step procedures. So here I'll directly go into the condition. Okay, so here the condition to be static, condition to be static or dynamic is if y and x. Okay, if y and x remains at the same state. Okay, remains at the same state means it is static. The same thing for dynamic. If y and x means nothing but input and output. Okay, it refers to input and output. Okay, output and input. If y and x remain at a different state. At a different state means the system is dynamic. Okay. So now you can take an example. So this is your example 21. Okay. As per your example 21, as per your example 21, so the given is given y of t equal to a into x of t. Okay. To find whether the system is to find whether the system is static or dynamic. Okay. This is what they are going to find. Okay. The solution, the same thing, put t equal to 0. Okay. Then y of 0 will be a into x of 0. Okay. So next, put t equal to 1. So we'll be getting y of 1 will be equal to a into x of 1. Okay. So next, put t equal to minus 1. Then y of minus 1 is equal to a into x of minus 1. So what kind of state the system is in? So you can type in the chat box. So what kind of state the system is in? I don't say it is a dynamic or static. You just tell me with respect to your present, past, or future. So this is in what kind of state? Whether it is in present state or it is in dynamic state, sorry, present state or it is in past state or it is in future state. So tell me with respect to that. So it will be coming with respect to the present state only. Okay. So y means y of 0 here you are putting. So here x of 0 is also the same state. So if you are giving the input as 1 means it is also coming with the same state. Okay, minus 1 means it is also coming with the same state. Okay, so like that you have to take into consideration. So it is in present state. So here your x position is same as the y position. So your x and y position are the same. So if your x and y position are same, then it is a then it is a what state with respect to static or dynamic usage. With respect to static or dynamic usage, it will be a what kind of system? It is a static system. Okay? So similarly, you can find other kind of examples. So for your understanding, you just take it out. So system will be dynamic means. So what are the systems in general will be dynamic means? So for dynamic, it will be your equation must be having either integration or differentiation or summation followed by a delay. So if these four are there means it will be your dynamic. That's all about your static and dynamic. So now we'll be moving to the last slide. This stable or unstable system. So based upon the stability, this can say the system as if it is stable means it is bounded input PIB4 system. So the expression for PIBO is bounded input followed by bounded output. Okay. So this is what your system will be like. Okay. So for this, if it is bounded input, bounded output means it is the stable system. Otherwise, it is unstable system. Okay. So now, what you can say means for a given amount of uh, equation, if the equation is in a particular range, it is in a particular range. That is, for example, if the system takes the value of infinity, then it is an unstable system. The system range goes with if the system takes the value of infinity within a range, so that's important. Within a range, so the range can be in they'll be giving in the problem. Then it's an unstable system. Okay. So here how we can find is that here you can take example 22. Example 22. So the given is what they have given is y of t they are giving as x of minus t minus 2. So you can say the system as PIBO system. How means this is a bounded input. So the input is varying within the range. So that is, for example, if I getting like this kind of any delay signal or any uh, positive signal, okay, T plus 2 if you are getting means it comes with the PIBO system. Okay, that is here it is defined. Here it is defined for any value of 0 if you are putting, will be getting x of minus 2. So it is a defined system, so it will be coming under PIBO system. Okay. So your trigonometric function like y of t equal to tan x of t. This is takes a value 0 to infinity. So this here infinity be possible. So it will be a unstable system. Unstable means it is not a VIVO. It's not a VIVO system, but you cannot say that all the trigonometric functions are not VIVO. Y in the sense means, for example, you can take y of t equal to cos x of t. So your cos will be taking a value of, what is the range of cos? Can anybody say what is the range of cos? Your cos function will take the values from which to which, from which number to which number. What is the range of your cos function? Can anybody say in the chat box what is the range of your cos function? Again, nobody will be answering. So I will be saying, so the range of your cos function will be from -1 to 1. Okay, it cannot be infinity. So it will be a bounded input and bounded output system. So it is a stable system. Okay. So that's all with respect to your types of system. Okay. So I'll be moving on with the next part. So the next part is, I have already covered for you in your the first starting of your unit 1. The same thing only I'll be again saying. Okay, the same thing what you have already I have shown you. Okay, it is theory part. So in terms of your problem, they will be asking from these kind of questions only. Okay, the type of signal, whether it is energy or power signal. Okay, from their question is possible, followed by your types of system. So what kind of system it is, and sometimes they might be asking in theory also. So explain static and dynamic system with examples they might be asking. Okay. So now we will be moving to the theory part. Okay. So the first unit is one half is the problem and the other half is the theory part. So the theory part we will be covering. So in terms of your lecture 6, okay. In a lecture 6, the C means that is, this is what your lecture 6. We have started with the static and dynamic system. We have covered it, followed by your stable or instability of the system also we have covered. So apart from this, in this lecture, we will be covering what do you mean by sampling theorem. The same thing I have already dealt with you. Okay, I have told you in the starting of the first class the sampling theorem. The same thing will be coming, followed by the quantization effect. Okay, followed by the quantization effect we will be seeing. So first one, so they have been asked to explain the block diagram about the digital signal processing. So this is what I have shown in the PPT. Okay, in the PPT we have seen about analog signal processing followed by your digital signal processing, right? So here they are saying about the question is about the digital signal processing. Okay, what is the digital signal processing? They are asked. So this you already know. So the same thing what I have dealt with the representation with respect to your diagram in paint. Okay, so in paint I have shown, right? So signal processing means what we have seen. Okay, so it's nothing but any operation that changes the characteristics of the signal. Okay, in general, your analog signal gets transformed into a digital signal. So that's what they are implying. Okay, here the characteristics include shape, phase, and frequency. Okay, so this is the theoretical part. And that's what they're saying. So most of the signals are analog in nature. Okay. So they are continuous with respect to time and space. Okay. So for processing, you need some filters. Okay, those filters will be working on your digital signal. Okay, so this is the analog signal processing diagram. The same diagram I have first shown in your PPT in lecture one, I think. Yeah, one. Lecture two I have covered it. Okay. So in terms of your digital signal, will be using some filters, then sampling plus holding, then you will be converting into A to D, then DSP processor, then D to A, followed by your reconstruction filter. Okay. So here, one new component you have to know with it is the anti-aliasing effect. Okay. Anti-aliasing effect is something what is based upon a anti-aliasing effect is something what you can say it is based upon your input signal. Okay, it's based upon an input signal is passed through a low pass filter. Okay. Why it is passed through a low pass filter? Why means there are many kind of signals. Okay, even if you are taking example in your power lines also there will be communication signal. Okay, so sometimes there might be possibility for electromagnetic interference to cause distortion in your power signal. Okay, so in such category, what happens is you have to remove the high frequency noises. Okay, so how you can remove the high frequency noises means you have to apply some kind of filters. So what this low pass filter does is it only allows the some signal, okay, which is of lower frequency. It removes the higher frequency and it only allows the signals which is of lower frequency. Okay. Here what they are saying is apart from adding some low pass filters, you can also add some notch filters. So notch filters are nothing but the filters that can remove a particular frequency. So here they are saying the frequency what they are adding is for 50 hertz. Why they are adding 50 hertz means it is nothing but your power frequency in your transmission line. So with respect to that, they will be adding this. So other things I have already explained with respect to your previous lectures. Okay. So the main advantages of digital signal processing is greater accuracy, right? Cheaper, they are cheaper. Easy for data storage. Data digital means it is very easy to for storage. Okay. Flexibility in configuration, time sharing. Okay. So the limitation is what is that? Power consumption. So bandwidth limitation. So the bandwidth limitation will be 2 times of your switching frequencies or sampling frequencies. Okay. The system is somewhat complex in nature. So this is what your digital signal processing. So this is to be a 13 mark. So you can expect that. The next is the sampling theorem. Okay. So this theorem, what it states is, in this theorem, you will be converting your continuous signal into a digital signal. So how it is possible? While converting such kind of, while doing such kind of conversion, whether your signal will be of same power or it gets distorted. So that's what is proven in this sampling theorem. Okay. So first they are defining the signal. Okay, x of n they are taking the band limited signal. Okay. So j into this is sigma. First they are defining the sigma. Okay. So here is the main thing, the sampling frequency. Okay, f. Here in general, the sampling frequency f is 2 times of your sampling. Sorry, 2 times of your normal switching frequency. So that's what here they are given. Okay. So sampling. So sampling also I have clearly shown in your lecture 2. It is the process of converting continuous time signal into a discrete time signal. So I have given the example for cutting out an apple. Okay. So cutting an apple means how it will be, and we are slicing it means how it will be. I have told you in the previous lecture. Okay. So you can just oversee it. So it is a continuous signal, it is a discrete signal. So it is similar to the cutting of your apple. Okay. So slicing. This refers to slicing. So the switch closes. Here the frequency is 1 by time period t. Okay. So next what they will be doing is they will be taking out the signal in terms of a continuous time period. Okay. So in the continuous time period, how your signal is represented, they will be showing. Then after that, they will be taking out the same signal with respect to your discrete form. Okay. So these kind of formulas are you have already studied in your M3. So this will be coming under your Fourier transforms. Okay. The same thing will be applying here. So here, what you have to notice, the integral width, that is the integral range will be of 2 pi by t. So this you have to take into account. Then they will be applying the formulas. Okay. That is, they will be trying to make the continuous signal with respect to your discrete thing. So you will be seeing in the next one. So this is what they are doing. So after that, you will be comparing your first and that is fifth and seventh equation over here. So here you will be getting will be equal to the number of frequency response. Okay, that is what I'll be saying is in general. So if this is of your discrete time period means, okay, so it is will be in the analog thing. What is the thing is it is summation of the signals. Okay, so in this sampling theorem, what I'll be saying is if you are converting a signal from analog to digital means, so in the signal will be having the same energy even if it is converted from analog to digital. So that's what they are implying. So next is the quantization effect. This is very, very important question. So the whatever now I covering is belongs to your 13 mark. Okay. So this you already know. The process of converting a discrete time continuous amplitude signal, that's nothing but x of n, into a discrete time amplitude signal, discrete amplitude signal. That is your continuous is changing into digital. Okay. Or here you can say discrete amplitude signal. So first class we have seen about continuous signal and discrete signal. So the same thing only here also. How it is done means it is done by rounding off of each sample in x of n. So this I will be showing in a diagram. So near the quantization level. So that is there's a particular level called quantization level. So if it is coming, if it is under that criteria means, so then the signal will be round off. Okay. So for this is the range. Okay. So for the range, it is determined by this equation. Okay. So this is the thing. Okay. So this dot represents your sampled value. Okay. So the quantized value is this thing. Why I am saying this? This is your continuous signal. Okay. So this is your sampled value. So it must be like this. But during quantization, it takes to the round off value. So round off value here is 0.10. So this value will be taken So the in between value will not be taken. Okay. So that's what here it is implying. So the same thing only they'll be giving out. Okay. So this one, if you're reading itself, you can just understand it. So from this, you can surely expect these two questions. If you're studying means sampling theorem and quantization effect, if you're studying means, surely you can attempt one half of the uh, one half. Okay, in this unit. Okay. Yeah, this I am saying for your university, from university point of view, I am saying.